So the next is Tony Ferrrante, who actually came to us out of the medicine department at Columbia. He sort of moved up the line into the Berry Center, and within 3 or 4 years of being there, made what I think many consider to be, again, one of the seminal discoveries in the area of diabetes, which is the fact that there are immune cells in the body called macrophages, which actually account in terms of their presence not only in the adipose tissue or fat of individuals or patients, but also elsewhere in the body, including the islets where the insulin is produced, that these macrophages actually account themselves for a very large fraction of the so-called inflammatory or inflammation biology that accompanies some of the circumstances that attend various types of diabetes. And this paper that Tony published along with a graduate student in the Berry Center is one of the most highly cited manuscripts in the past decade in the medical literature. So if you look up Ferrrante and his citation index, you will see thousands and thousands of citations of this paper, the implications of which actually are growing day to day. That is, it's now increasingly realized that these cells play a very major role in several or virtually all types of diabetes. And for this reason, we cherish Tony's presence and would like to encourage his continued work along these lines. But Tony can tell you a little bit more about this.
So thank you, Rudy, and thank you all for coming. So I'm interested in fat, and the thing, as my son says, nobody really wants Papa. And what, being married to someone with type 1 diabetes, I've known for more than 20 years the importance of immunology in type 1 diabetes. But as Rudy alluded to, about a decade ago, we found that the immune system also plays an important role in type 2 diabetes and also just in general in the function of fat. And so much of the work that we do in our lab now is trying to understand how the immune cells function in fat, and more recently trying to harness them to make the fat, as it were, better. When fat doesn't function well, it ends up impairing metabolism not only of lipids and fat throughout the body, but of proteins and most importantly, glucose. And so if we can change the way fat functions from bad fat to good fat, then we can really improve the action of insulin in people with diabetes from type 1 or type 2. And also, more recently, sort of the exciting work that we're doing is trying to actually use the immune cells to, as it were, melt away some of the fat, or get the fat to say, don't put any more fat in me.